For number 21, they're asking you which of these is a horizontal asymptote of y equals 5. So what I'm going to do is I am just going to use a definition of limit. I remember that as long as the leading terms match as far as exponents go, it's just a ratio of their leading coefficients. So the ratio of 20 to 4 is equivalent to 5. So there's your y equals 5. This is choice E. Number 22, to derive this, I'm going to do the quotient rule again. I'm going to do x times 1 over x minus 1 times ln x all over x squared. Simplifying, I get 1 minus ln x all over x squared. Now, to discuss about absolute minimums and critical points and possible points of inflection and whatnot, I'm going to set the first derivative equal to 0. Cross multiply, you essentially get 1 minus ln x. So solving for that, I get ln x equals 1. Where does ln x equals 1? X equals E. Remember, that's because the log base e of x is the same as ln x. So since log base e of x is equal to 1, basically just replace it with substitution, rewrote it in exponential form, e to the first equals x, therefore e equals x or x equals e. That's how I got that. Now I'm going to create a number line for myself. I know that e is about 2.7 something. Okay, so if this is, I'm going to pick a value less than that, so how about 1? So what I'm going to do is say 1 minus ln of 1 all over 1 squared. Now ln of 1 is 0, 1 squared is 1, you get 1 over 1. This is a positive number. I know that this region here, this interval is going to be positive. Now I'm going to test a value bigger than e, and that's 3, so I plug it in, 1 minus ln of 3. This is 1 minus, now n of 3, again, you have to kind of know your graph of ln. Okay, this is where it's 0. Okay, ln of 3, well, the y value is 0. This is 1. The y value is 0. Therefore, at 3, it's probably greater than 1. So I'm going to say it's something larger than 1, so we'll just pretend that it's like, I don't know, 3, or no, it can't be 3, it's like 2 point something, I don't know, and over 9. Regardless, 1 minus that number is going to be a negative, and a negative whatever over a positive is a negative. So this region is negative. So because it goes from positive to negative, that means it's an absolute maximum. So I'm going to take that critical point and I'm going to plug it back into my f. This is 1 over e, choice B. For number 23, the best I can tell you right now is that similar to number 17, linear growth means a constant rate of change. And if all these are my rates of change, notice how all these have variables except letter A. For number 24, for a critical point, what I'm going to do is find the derivative. What I'm going to do for that is to use the product rule. First term times the derivative of the second term. Now remember, you have to differentiate that. So the derivative of kx, if k is a constant, pretend it's like 2x. What's a derivative? It's 2. So I'm going to say k plus 2x times e to the kx. I'm just going to neaten this up a little bit. I'm going to have kx squared e to the kx plus 2x e to the kx. I'm going to set this equal to 0. So now what I do here is, what I did was I factored out an x and an e to the kx, and I'm left with kx plus 2. Setting both of these equal to 0, the only way for this to be 0 is for x to be 0. So what I'm going to do here is say kx equals negative 2. Now the question says, for what value of k does g have a critical point at x equals 2/3? So what I do is say k 2/3 equals negative 2. I multiply by the multiplicative inverse. I get k equals negative 6 over 2. k equals -3, and that is choice A.